This is the Smart Buildings Academy podcast with Matt Scott and Ethan Morris, episode 496. Welcome to the Smart Buildings Academy podcast. Today's episode will be about VRF systems. All the information covered in this episode can be found on our website at podcast.smartbuildingsacademy.com/496. That's podcast.smartbuildingsacademy.com/496. So, Ethan, VRF systems are making a huge splash in the HVAC world. Why do you think it's so relevant for BAS professionals today?
Matt, VRF today is no longer a niche market. It's widely adopted in commercial, institutional, and even residential spaces in today's HVAC world. It introduces a new layer of control complexity that BAS techs must understand because it's going to become the way of the future. It also represents the convergence of mechanical and digital systems, which is exactly what us BAS professionals manage daily. Before we dig in, Matt, to VRF, can we set the stage for today with a quick overview of what today's episode is all about?
Yeah, absolutely. So, we have a couple topics for today's lesson or today's podcast. We're going to talk about or walk through how VRF started, so the origins behind it, and why it's different from your traditional systems that we might see. We'll also explain all of the components, benefits, and integration challenges that come up when we deal with VRFs. And also, we'll look ahead to where the VRF is going in the smart building world. So, first, let's take a look back in time and check out our HVAC world. So, let's rewind to 1902. What were HVAC systems like back then? And what were their biggest limitations when dealing with them?
They weren't great. they, they were really, really big, noisy, and very inefficient. They weren't. I don't think there was a lot of thought put into them when they first came out. I think it was just kind of we have to have something, so let's do this. The
Yeah.
early systems were designed more for like process control, things like printing presses,
Mm,
industrial type buildings. They were more made for that than occupant comfort. And back then, there was only a basic temperature control. They didn't really have much in the way of zoning or modulation. And of course, with things being big and bulky and noisy, the energy usage was much, much higher.
yeah, and they didn't really
Um,
know back then either.
right. Yeah. No, unfortunately, but we've come a long way.
Definitely.
So let me ask you a question, Matt.
Yeah.
How did those limitations lead to us having a need for something like a VRF system?
Yeah, definitely. So as our energy costs rise, right? I mean, we're always seeing an energy rise or cost, and buildings are
Right.
becoming more and more complex. I mean, there's just different systems that we're coming up with, and the
Right.
buildings we are trying to get more, we're trying to integrate more systems within our building. And so that
Hmm.
one size fits all, where you have the big system and it's just supposed to push air to the entire building, just doesn't really make sense unless it's some
Right.
low efficient or some low requirements or low hanging fruit when dealing with HVAC. So
Yep.
engineers kind of were looking for something where they could zone it, right? Zoning is a big thing in our industry, and
Sure.
finding ways to have a better part load performance, and of course being flexible as well, being able to modulate how much air goes into different spaces at the same time was such an innovation that they had to come up with some way to do that. So this opened up the door for refrigerant based systems. Now that way that they could adapt to these dynamic loads, having different loads in different spaces all at the same time. So they had to adapt or die essentially.
Yeah.
Um, so my question back would be, Japan in the 1980s is often cited as the birthplace of VRF. It's pretty much where it came from or where it was designed. What made that region the ideal launch pad? And I think I kind of have an idea.
So, funnily enough, a lot of Eastern countries are highly populated, and they're highly
Hmm.
populated. Their population density is massive within a small area. So, in the 1980s, Japan, yes, you're right. It was the birthplace of the VRF. Actually, Daikin was the first manufacturer of what they called the VRV, which is variable refrigerant volume.
Yeah.
A lot similar to variable refrigerant flow, which is the VRF. But they kind of coined the term VRV. But the reasoning for all of that is because of the high real estate density. Lots of people packed in small apartment buildings, small footprint buildings. So space was at a high premium. The other thing was high electricity costs. They created a demand for energy efficient solutions, trying to make things run a little bit cheaper to help with infrastructure. So, like I said, in 1982, Daikin launched the very first VRV system, which obviously once they got it all figured out, the rest of the globe took notice, and now in 2025 we're seeing these VRF systems scattered all over the planet, which is amazing. I mean, this is going to be the future of HVAC.
Definitely.
So Matt, I'll switch gears just a little bit here. I think we should go through and kind of explain what a VRF is, what it does, how
Yeah.
it works. So if you can kind of in plain terms give me what a VRF system is and how it differs from what most techs are used to in a traditional system.
Yeah, absolutely. So VRF, and you kind of touched on what a VRV is. It's similar, right? A VRF
Hmm.
stands for variable refrigerant flow, which means that we are controlling or modulating the amount of refrigerant that we send to each indoor unit. So each unit that is conditioning a specific space. So this way, we are enabling or we're allowing for a simultaneous multi-zone operation. As I mentioned, you can send different amounts of air based on that variable flow to different areas or zones, as we call it. Because a lot of times we'll take multiple rooms, we'll put them together on one zone because they have similar attributes. So they have similar load requirements. And so being
Right.
able to control the amount of air in each of those zones is crucial or key, right?
Oh
So
yeah.
VRF allows us to do that in a very efficient way, whether it's heating or cooling our spaces independently. So you can have one heating and one cooling depending on what may be going on in that area. Maybe the sun's really hot and on one side, and the other it's still 50 degrees out. So we're able to vary
Yeah.
that as well. I mean, that's huge, right? The other
Right.
thing, the other thing that we see or that separates VRF from the other systems like DX split systems is that we have our advanced modulation and control strategies. They actually have come up with ways to control it without sacrificing the energy efficiency the lack thereof in the DX.
Okay.
Yeah, so my question back would be, can you tell me how the zone-based controls do work in a VRF setup?
Sure. So we'll go over a little bit more of the components in depth here in just a few, but just to give kind of a brief overview of how VRF zoning works. So you'll have typically with a VRF system, you'll have the condenser up on the roof, and sometimes that can have one, two, or three cells, which is basically just one, two, or three condensers. They're kind of linked together. And then you have the refrigerant piping, of course, and then you have if it's a heat recovery system, which is majority of what we're talking about here today, which is a three pipe system. You'll have branch selector boxes. Sometimes those can be set up in a one-to-one style marriage, so you'll have one branch selector box per indoor unit, and that is what allows independent heating or cooling between all the zones. Um, so with each indoor unit, it'll have its own thermostat and EEV, which is an electronic expansion valve. And with those things, the system can react to the real-time load conditions and make changes pretty quickly and pretty efficiently. Then the outdoor unit will ramp up or down based on the total building command. And then we'll also talk a little bit later about a two-pipe VRF system, because there's also a kind of like a traditional heat pump style system that you can have in a VRF setup as well. But like I said, for today's podcast, we're mostly talking about the three-pipe system, which is heat recovery. So, but that's just kind of a basic overview of how it works, what all the components are. But like I said, we'll go into a little bit more detail here in just a bit on all the components and how they operate. So question back for you, Matt, is what exactly is varying in a variable refrigerant, I'm sorry, a VRF system?
Yeah, definitely. Well, obviously, hence the variable, right? So there's a lot
Yeah.
changing or a lot
Yeah.
adjusting on the fly.
Right.
One thing, of course, is the refrigerant flow rate, which is what it stands for, but
Mm-hmm.
also the temperature and pressure that's associated with that. Those allow us to change the amount that we're providing. Also, the speed of our compressor or the inverter portion of our compressor, and the position of the expansion valves per zone, how much we need to open and close those valves based on the load requirements. So there's a lot
Yeah.
going on in these moving parts, but they're all
Sure.
efficient and effective and easy to control. And I think you kind of touched on that, where it's kind of the wave of the future because we can control these in such a fast way. They
Oh
react. The
yeah.
timing on them is very quick and efficient. All
Right.
right, let's talk about the hardware a little more now. So, what
Sure.
are the core components in a VRF system?
Okay. So like I said, I briefly touched on this here a second ago, but the main components in a VRF system is you'll find an outdoor condensing unit, which will have the inverted compressor in it, sometimes multiple compressors, depending on the manufacturer and the unit. Then you'll have multiple indoor fan coils. These can be ductless or they can be ducted. Then you'll also have a branch selector box for heat recovery systems, which is what I was saying a few minutes ago. Heat recovery systems will be a three-pipe VRF system, and then the branch selector is what allows these individual zones to select either heat or cool individually. And also in these branch selector boxes, um, I like to akin them to a reversing valve in like a typical heat pump system. It's kind of just a simple four-way valve is all it is. But again, that branch selector box with that reversing valve, quote unquote, is what allows you to select between heat and cool for any zone, multiple zones, individual zones. Then you have within the indoor units, you have the EEVs, which are the electronic expansion valves, and these are different from a thermal expansion valve, which is what traditional systems used. Electronic expansion valves are usually a pulsed valve, so it has a range of anywhere from 0 to 2,000. Um, Again, manufacturer baselines change how they operate, but most of the things that I've seen are a pulsed valve, so they open and close, pulsed very slow, open and close. Um, but those EVs, the reason they're electronic is because it can modulate the flow of refrigerant going into and out of the fan coil unit. So that also
Yep.
helps with your energy efficiency, things of that nature.
Yeah, definitely.
Um, so then another question for you, Matt, is how do inverter compressors and pulsed EEVs function together in a
Yeah,
VRF system?
good. Yeah, good question. And you kind of mentioned it there.
Yeah,
So
a little bit.
yeah, a little bit. So the inverter controls the compressor speed so that we can match the load. So as it
Okay.
ramps up, our load, or as our load gets higher, our speed ramps up and vice versa.
Okay.
Also, the EE, as you mentioned, adjusts the refrigerant flow to each of those coils, and that's based on the demand and what our sensor is telling us, right? We have that sensor feedback telling us, hey, this area needs more flow or more air, it needs to be colder, or whatever the temperature might be. So then it goes back and it adjusts that EEV. And then also, I guess, combining those two, we get this high energy efficiency, this high granularity of everything flowing together, working together in a pretty efficient system.
Yeah.
So can you explain to me what the difference between heat pump and heat recovery in VRF systems?
Sure. So typically nowadays you find more of a heat recovery system than anything because it allows for individual zoning control. You could have 30 rooms in a building. Well, if you have 30 branch selector boxes with those 30 units, you have each room can control its own heat, its own cool, and it can be different from any of the other rooms in that hallway. But a heat pump system in a VRF will still use an inverted compressor, so you still have that speed, that ramp up and down for your compressor speed. But the difference is that all the zones are either going to be in a heating or cooling mode together. You're not going to have that individual zoning like you would with a 3-pipe heat recovery system. Um, heat pump systems in a VRF are still pretty good, pretty good, pretty good system in my opinion. Like I said, they don't offer near as much customization as a heat recovery system would. But you're still talking about huge energy savings with a VRF heat pump, and there's just a little bit less of a need for them now than a heat recovery system. It's 2025, so everybody kind of likes to control their own thing. And then a heat recovery, which we've talked about this one already for a few minutes, but I'll touch on it again. Heat recovery system is going to be a 3-pipe system, and that third line is what we would have called the parallel line, but this will let you simultaneously heat and cool multiple zones on a system using the branch boxes and that 3-pipe system. Heat recovery systems offer higher energy reuse, but they require more advanced design and controls when you go to start these up too. Which we'll go into a little bit more of the control side of these later on in the podcast. But for now, but yeah, heat recovery systems are great. Just have to take a lot of time and effort when you go to install and commission these things, which we'll also talk about that in a little bit too. So another question for you, Matt, is from a BAS perspective, how does the communication work on these VRF systems?
Yeah, so a lot of them are proprietary from a protocol standpoint.
Right.
And that includes the integration. So with integration, we require either something like a BACnet or a Modbus gateway. Some could be native, others third party, depends on the system and what we're trying to do. One thing that we teach in our workforce development is coming up with a points list and looking at the different sequence of operations. So the VRS system is no different from that. So your controls team, when they're trying to get this communication all to function, they need to do a map points list where they, take all the different running parts and sensors, everything it requires. So like the compressor speed, the zone status, and any alarms that might go off, they need to map all that out. That way they're understanding that this all can communicate and talk together. Yeah, there's a lot of that going on.
And I will say too, some things I noticed when I was in the field, there's not a lot of control integrations, at least in my area, there wasn't. I did a lot of startup and commissioning and installation on VRF systems. And they had, it was always a real pain to try and integrate controls in with a lot of these VRF systems because of what you said, where a lot of these use proprietary protocols. Well, you have a lot of these third-party manufacturers that are creating the controls for these, but they're not testing any of it. So they'll send them out into the field and say, well, yeah, it works. We know it works. But then come to find out after you get it wired up and hooked up, it doesn't. So My advice to anybody that's listening would be to, when you go through the design process on this, make sure and then make sure again that your control setup is going to work with what equipment you have, because it can save you a lot of time, a lot of headache down the road.
Yeah, that's pretty good advice. Definitely. Yeah.
So how does sorry, excuse me, how does VRF compare to a traditional DX system?
Yeah, so quite a few ways, right? DX systems, for one, used fixed speed compressors, so it doesn't
Hmm.
variable the speed of the fan, right? So we're using just the
Right.
fixed speed of that compressor. And they also have pretty poor part load performances. Now,
Yep.
VRF systems, on the other hand, they use that inverter tech so that they can match the building load, like we talked about, right? It'll ramp up the
Right.
compressor, ramp it down. That way, we're matching the building load, which is much, much more efficient. The
Right.
VRF also allows only one unit or one outdoor unit to serve multiple zones, right? So that's a lot different when we have a DX system where we have maybe a VAV box or something. That VAV box is only serving that zone, right? And so we have a
Yep.
different VAV box or fan coil unit, whatever it might be. They're serving specific zones. They don't serve more than one. So a VRF can actually hit multiple at the same time, which again is
Yeah.
efficient and effective. Now, what
True.
about hydronic systems? What's the difference there?
So, with hydronic systems, and I mean, we can be honest here. I mean, hydronic systems are always going to be a thing. They're always going to be around. It's
Yeah.
for large scale buildings, large scale industrial operations. Hydronic systems are they're unmatched. Scalability of
Yeah.
those is, we're never going to be able to get. I don't think there's ever going to be a time where VRF systems, at least in my opinion, are going to get to be large enough that they can handle these large central plants, industrial areas.
Yeah,
Um,
probably not.
but hydronic systems, they still allow energy transport without the refrigerant limitations. They still have a huge value when it comes to these larger buildings, and that's something else we'll talk about as we go forth too, is the cost of these VRF systems. They're not cheap to put in. Hydronic systems with these large plants is just, I think it's a little bit more feasible to go with a big chiller plant, boiler plant.
Yep.
In the long run, I think it just makes things a little bit easier. VRFs are often better for smaller buildings or retrofits, when there's a limited
Yep.
footprint, and you don't have very much space in the building for fitting things like ductwork. Or if
Hmm.
it's, I've had a
Exactly.
couple instances where I've worked in a historical building and they don't allow you, you're pretty limited on what you're allowed to demo and what you can't.
Yep.
So buildings like that, VRFs are great because you can get in tight spaces. You don't really have to modify a lot. You're really just talking about running some refrigerant piping to all these different zones, and then you're pretty well good. Um, so again, I don't think hydronic systems are going to go anywhere. I think they'll be
Yeah.
around for the foreseeable future.
Yep. I would agree with that.
But if they can get the scalability down for VRF, and then figure out some of the refrigerant limitations, I think they could do something with those. But moving
Yep.
on, when would VRF not be a good fit, do you think?
Yeah, and you mentioned one of the big reasons, right? And it's that the large buildings or plants, centralized
Oh yeah.
plants, those kind of size buildings and the scalability, as you mentioned, the water. I just don't think it'll ever be there, as you mentioned with VRFs. So I would
Yeah.
say anytime there's a large building, you probably don't see that. You'll see a chiller plant, right?
Oh yeah.
Anytime there's a cold, or very cold climate, that way, because of the vapor that comes along with the compressors, we don't want them to freeze up. And so
Right.
if it's a very cold climate, we have issues there. And then another thing that these do require are a decent amount of electrical infrastructure for our compressors, right? So there does need to be some electric work there, or the ability to house these from an electrical standpoint. Now, let's talk a little more about smart buildings and who we are and how it can relate to us. So for the VRF, what are some of the top energy benefits for those systems?
Obviously, a big one is energy savings. Um, the savings you get are because of these systems running at a partial load most of the time, which cuts back on your energy usage uh, quite a bit.
Yeah.
Then we've got the use of heat recovery, which captures and reuses the waste heat. So that in and of itself is also another way of saving energy. Um, Another benefit would be reduced cycling and staging that reduces wear and the peak demand on these components like the compressors and the EEVs. And having maintaining these systems can be uh, a little bit of a bear sometimes. That there's a lot that you have to do. There's a lot you have to maintain, but you keep up the preventative maintenance on these and stay with them and monitor them well, these you won't have any issues with these. But a lot of these energy benefits, you'll see a lot of these energy benefits pretty quickly if you install these systems, especially if you compare them to a traditional style system. If you had a DX system that you were running before you put this VRF system in, you'll see these energy saving benefits in no time. Another question for you is, how does VRF support better comfort from traditional systems?
Yeah. We talked about this a little bit, but obviously each space, as we were talking, is independently controlled. So
Right,
that obviously supports better comfort because, again, if you're on one side of a building that the sun's facing and it's real hot in that room, we can adjust that and control that room as opposed to other
true.
rooms. And so it depends on what space you're in. You might have different requirements or load requirements. We also
Yeah,
kind of mentioned the fact that they have faster response times than most of our air-based systems, right? We can react
right.
quicker, which again, if I'm sitting in a room for 20 minutes or an hour or 2 hours trying to get that thermostat to show, go from 74 to 70 or whatever, if it's hot out, it might take a while in those air-based systems. So the response time
Right.
is critical, right? Especially
Yeah.
in something like a classroom where kids might only be in the class for 50 minutes, right? So like if we're trying to
Oh yeah.
adjust those systems and it takes that long to get into or to get to where we're trying to go from a set point standpoint, it might not be very effective to be trying to cool that the entire hour that they're in there, right? And
Very
then
true.
another would be where we can actually fit, and we kind of touched on this as well, but it's quiet, right? There's not a lot of,
Oh yeah.
in like a historical building, not only is it a space thing, but sometimes it's a quieter operation they care about, right? If we have big ductwork and
Right.
there's air bouncing around and you hear the motor and the fan and all of that stuff, it kind of reduces that by quite a bit, right? It's a quiet
Oh
operation
yeah.
and there's just better control over our discharge temperature in general. So we have just a variety of different ways that we can support comfort.
Yeah.
Um,
And I will
and
say
you,
too,
yeah, go ahead.
in some of my experiences, those were some of the best compliments I've ever gotten on the VRV systems.
Was
Were
how quiet it was.
they're how quiet they were,
Yeah.
how efficient they ran, and that people loved having the individual control in their offices instead of having,
Mm,
like
exactly.
a typical VAV system where you'd have 5, 6 rooms with 6
Yep. In
VAV
one
boxes, but
zone.
one thermostat. Yeah, but one thermostat to run them all. People don't like that.
No,
So,
definitely not.
but yeah, it's the uh it's the variable speed is what helps with the quiet operation on these. And a lot of these indoor units in the thermostats have a variable speed fan, and you can set those usually 0 to 100%, and then they give you a adjustment button on the thermostat so you can change them. And I mean,
Yep.
like I said, people love the quietness, the quiet operation of these. So I would just add that in there too.
Yeah, absolutely. No, yeah, perfect. Yeah, so and you mentioned this a little bit, but why is a VAF or sorry, a VRF ideal for retrofits like you were talking about and maybe some more urban environments as well?
Yeah. So, yeah, you're right. I did touch on it just a little bit, but for retrofits, like I said, this could be a old courthouse or something that's a historical site. So there's laws and regulations that won't allow construction crews to get in there and take out a wall or lower a ceiling or something. They are limited on what they can do. So with these VRFs, you get a smaller equipment footprint. So every piece of equipment with these is smaller than the old typical chiller or boiler and air handler. Um, you can have longer piping runs because you don't need the duct work. So you can run refrigerant lines across the whole building. You'll have to check in the manufacturer's manual for these just to make sure you're not over length. And there's usually a lot of stuff in there about inverted traps or stuff for oil return, which we'll get into that a little bit here in a bit too. But the without the duct work, you don't need. I think I talked about this a little bit earlier too. But without the duct work, you don't have to cut big holes through walls. You're talking small hole for 3 refrigerant pipes or a huge massive hole for 12 by 24 duct or something.
Yeah.
And then to add on to the smaller equipment footprint, a lot of these VRF systems will fit where traditional air handlers and boilers and chillers just can't. It's
Hmm.
that smaller footprint is huge also because you don't have to worry about setting a chiller out in the parking lot and you're losing parking spaces. You could set
Yeah.
this up right next to the building on the ground. You can set it up on the roof. That's one great thing about the VRFs is how versatile they are when it comes to installation and how they're set up. You just can't beat them.
Yeah. Agreed.
So moving on here. Um, okay, we've talked about some of the good parts of VRF, so let's start talking about a little bit of the bad. What do you think some of the main drawbacks of VRF systems are?
Yeah, definitely. There's a couple that come to mind. One is the initial cost of it is
Oh yeah,
extremely high, and that's
yeah,
because I mean you pay for technology, right?
right.
The the VRS systems like they're more um, technology or technologically advanced. I mean, there's
Oh
more
yeah,
more to it, more engineered aspects to that, to where it is pretty pricey. Not gonna lie.
oh yeah, yeah.
It's also pretty sensitive when we're installing these systems. There's the line lengths have to be exact, they have to be spot on.
Hmm.
And like you said, there's some oil return issues as well on those. So we got to be
Yep.
careful with that, right?
Oh yeah.
And then the other thing is that there's more commissioning than the average DX system or any of those type of systems. There's just more that needs to be done, and you also have to make sure that the refrigerant is validated, right? The charge is validated. So we need to make sure
Yeah.
all of that is going on, and that's just something that you don't necessarily need to worry about with our traditional systems.
Yeah.
Um,
I will add too on this.
yeah,
There's the high initial cost can scare away customers, but if there's one thing I've seen the most with these VRF systems is your second point, the sensitivity to installation errors. You know,
yeah,
when I first started coming up with the VRFs, learning how they work and how to troubleshoot and diagnose all this stuff. One common thing I heard a lot from people that knew pretty much everything about VR, who I learned from, was when you get out on these jobs, you have to ensure that whoever the installing contractor is, that they install these things to a T, to the book, has to be correct. And a lot of times these they'll send these contractors to a class for installation,
mm,
because there's a lot of ins and outs on these. You nailed it when you said there's a lot more technological advances in these than a
yeah,
typical or a traditional DX system would have, and that's the truth. So another piece of advice I would offer to anybody that's watching this is when someone tells you about the installation practices on these, which is another, by the way, another video, another podcast in the series that I'm going to do with this.
Mm,
Installation has to be done right the first time because
yep.
it will save you so much time and money in the long run. Um, and the commissioning and all that stuff can be done. You know, that's not too bad. But if there was one thing I had to tell people with the VRF systems, make sure it's installed correctly because it will bite you big time if it's not.
Yeah, definitely. No, that's yeah, good point. So in that, I guess in that same breath, what are some of the training gaps that you see with BAS techs and VRF systems?
So I know VRF has been the technology's been around since 1982, but you know a lot of this stuff hasn't been put in. You know, we just started getting these in America in 2010, 2012, I think. So you know they haven't been here very long. So it's still a little bit of a niche thing for technicians, not people buying and installing, but for the people working on them, it's still a little bit of a niche thing. But I think a lot of it is that a lot of technicians are strong with airflow, but they're weak on like refrigerant theory, like how the refrigerant's supposed to work, how these EEVs work in these systems. I think there's also a limited understanding of the EEV logic, you know, how those things are supposed to open and close, things like pressure curves or subcooling analysis. I think there's just a lot of traditional systems you didn't have to deep dive into stuff like that, but with these VRF systems you do. You know, there's just like I said, there's so many ins and outs. There's so many electronics in these things, and that kind of leads into my third point on this is that the controls integration it often lacks visibility between beyond the gateway points. And I
Yep.
think you had talked about it earlier, but you know, when you go to integrate controls with these VRFs, a lot of the time you have to use a third party manufacturer controller because everything's proprietary with these VRF manufacturers. So there's not a lot that you can do um, with like proprietary controls because a lot of these VRF system manufacturers don't make controls. You know, a lot of times you have to go out and find somebody else that's compatible with a VRF system that you're working on. But though I'd say those are just some of the training gaps. Knowing how to, I think a lot of times it's that people get overwhelmed with them because there's so much happening in them all the time. Um, but I think it's getting better over time. I think the more people go to schooling on these and learn more about them, I think they're passing the information along to newer guys, and then the more that the newer guys are working on it, they're getting a little bit more comfortable. And I think it'll turn around as we see more BRF integration here in the U.S. But I think those are the main training gaps. So
Yeah.
we only got a couple more questions here, but
Yeah.
next one I have for you would be how can BAS teams reduce integration risks?
Yeah, definitely. I think one important thing is having them have them be a part of the design phase. So like when the engineers on the HVAC side are designing these systems, that the BAS techs or the designers are there with them, understanding, again, we talk about the sequence of operations. If they know that ahead of time, they can mitigate any of those issues by planning and designing as well. Because sometimes the HVAC engineer might not know that it would be better to do something else. Like there might be some advice that the BAS designers have in order to have a better operating system. So being a part of that
Mm-hmm.
design phase is crucial. I'll also say that using the certified integration kits from the OEMs themselves, right? You touched on that. Like the
Oh yeah,
proprietary stuff is also crucial. And then
right,
just being able to find and be trained on any of those fault codes. If you don't know how to troubleshoot the system, you're not going to be able to use it to its full potential. And you're going to have a lot of issues if
right.
you can't troubleshoot, right? So using those
Oh yeah.
diagnostic tools, I would say, is another thing that they could do.
Yep,
Um,
for sure.
so so let's we have a couple more questions here, and then we can wrap this up. Let's talk about the
Yep.
future of the VRF. So where is the innovation heading in these systems?
So I'm really excited about this, and I think with AI coming up, I think AI is going to play a huge role in VRF, which is great because um, how how technologically advanced these VRF systems are. I can only imagine what AI can do for technicians or building operators or building owners as we go through, the next decade or so. But um, I think a lot of the innovation is heading more towards cloud diagnostics and remote monitoring platforms. I know Daikin, when I came out of the field, was working on one called, I think it was One Cloud, but it was basically a cloud monitoring service. And sites could buy a subscription from them, and then they would monitor 24/7 all the systems on your building, and then they would send you notifications if anything was wrong. So I think there's a huge market for that too. Um, Predictive maintenance using onboard sensors and AI analytics. I touched on the AI thing just a minute ago. There's just so many different scenarios that I can see AI going with, not even just VRF, but HVAC in general. I think there's going to be a huge collaboration, next decade or so with AI and HVAC. Last part on this would be auto commissioning routines and smart load balancing. Trying to take a little bit more of the work off the tech, make things a little bit easier, more streamlined. Um, okay. We'll call this one the last question for today, and we'll wrap up after this one.
Yeah, sounds good.
So last question for you, Matt. How does VRF align with sustainability goals?
Yeah, so there's a lot of sustainability possibilities that we have with VRFs. So one is that they work well with solar and battery systems, which of course are popping up everywhere. And the more
Oh
we
yeah,
can utilize our solar panels and our systems with batteries and solar, we're going to be able to power those with our VRFs. It would be huge, right? I mean, that's such a cool
right.
integration that's going to
Oh
save a
yeah,
lot more energy.
right.
And again, as we mentioned, there are lower energy usage when we have our peak demands and any of those seasons where we actually need to be more concerned, like in the hot summer, obviously your energy bills go up. These can lower those energy bills based on the amount of energy we're using, right? So from a
Very true.
sustainability where we're concerned about energy, I mean, I think we've touched on it so many times, but it really does save you energy. And
Yeah.
then
Yeah.
the other thing that's a really good point here is the the footprint that we have with our mechanical plants and the fossil fuel systems to run those
Hmm.
are something that maybe doesn't get acknowledged as much because we talk about the energy part of it, right?
Right.
But
Oh yeah.
also the amount of fossil fuel that we use, right? All our ASHRAE stuff that we talk about from a
Right.
sustainability standpoint, it
Yep.
reduces the need for those. So we don't need big plants and all of the carbon footprint that they also provide. So having that
Absolutely.
would be huge, right?
Oh yeah, I agree.
Well, that concludes this podcast. Great time. So
Yes,
thank
thank you.
you. Yeah, definitely. So thank you for listening to the Smart Buildings Academy podcast. We hope you learned a lot from this episode. If you found this episode valuable, please leave us a 5-star review on Apple Podcasts or Spotify. If you're watching this on YouTube, please like, comment, and subscribe. And if you're watching this on LinkedIn, please share this with your network. As always, this will be available on our website at podcast.smartbuildingsacademy.com/496.